The shell sort, or as it's sometimes called, the diminishing increment sort, is the first major move away from linear searching of the previous algorithms. It builds upon the insertion sort by dividing the list into a series of sublists. Instead of these sublists being solid blocks, they are divided amongst the larger list, with each item in the sublist being divided by a number of items represented by I, or the increment. Each of these sublists are sorted amongst themselves using an insertion sort, and then the new sublists end up looking something like this. While this list still isn't ordered, as you can see, it's a lot closer to an ordered list than what we had before. Once we have this, we run a quick insertion sort over our final list to get our final sorted list. Well, we're going to start with a template from the GitHub account again, and as you can see, it has two functions. The first is the overall shell sort, and the second is our shell insertion sort that will run on each shell. Okay, so I'm going to start with our sublist sorting function here. Now, as you can see, I'm just cheating by copying our insertion sort code from the insertion sort problem into this function, and we're just going to change a couple of things. The first thing is this one up here. We want it to be start plus increment. So this function gets called for each of the sublists with a starting point, which is the first increment of that sublist. So start plus increment gives us our starting point. The other thing we want to change is how much we're jumping up for each number that we're checking. In this case, we want to jump up by our increment. The other things we want to change is this 0 here, which is our endpoint. Again, we want to greater than or equal to our increment. We want to change this to our increment, this to our increment, and finally this here to our increment. So that's got our insertion sort for our list set up. Okay, so the next thing we want to do is with our increment. Now we want to start this out at looking at half the length of the list, and we're going to keep on reducing that down by half until we get down to 1. So I equals len numbers floored half, which gives us that nice even number. While I is greater than 0, we're going to continue doing our bit. The first thing we want to do is flesh this out with another loop with the start positions for each of our shell sorts. So for start in range, going up to our increment. So what this will do is it will give us all the start points up until we get to the point where we'll start repeating things. And then we want to call shell insertion sort with our numbers array, our start point, and our increment. Okay, so that will do that for every one of our sublists. And now we want to decrease our increment by half again, and we want to make sure it's floored. So we're going to just test this out. I just need to change one thing down here. Okay, there's our ordered list. So what's the efficiency of this function? Well, at a glance, you'd think it'd be more complicated and slower than the previous functions, but it's actually more efficient because each time the numbers are shifted, the shifts are smaller and the actual performance is slightly better. The final performance that we get out of this is somewhere between n and n squared, but the actual measurements are more complicated than that because of all the overheads.